In the silent expanse of the cosmos, stars have been shining for billions of years, illuminating the universe and driving the cycles of matter that give birth to planets, moons, and even life itself. But like all things in the universe, stars too must face their inevitable end. The death of a star is one of the most awe-inspiring and catastrophic events in the cosmos, a process that gives rise to some of the most exotic and mysterious phenomena known to science. Today, we'll explore the life cycle of stars and the many ways in which they meet their demise, from the gentle fading of a small star to the cataclysmic explosion of a supernova. To understand how stars die, we must first understand how they live. Stars are born from vast clouds of gas and dust, known as molecular clouds, that collapse under their own gravity. As these clouds contract, the material at the center becomes increasingly hot and dense, eventually igniting nuclear fusion in the core. This marks the birth of a new star, which will spend most of its life in a stable phase known as the main sequence. During the main sequence, a star fuses hydrogen into helium in its core, releasing an immense amount of energy in the form of light and heat. This energy provides the outward pressure needed to counterbalance the gravitational forces trying to collapse the star. For stars like our Sun, this phase can last for billions of years, a period of relative stability in the life of a star. But this stability is not eternal. Eventually, a star will exhaust the hydrogen in its core, and what happens next depends on the star's mass. The death of a star begins once the hydrogen fuel is depleted. The fate of the star is determined by its mass, leading to two distinct pathways: the gentle death of a low-mass star and the violent end of a high-mass star. For a star with a mass similar to that of our Sun, the depletion of hydrogen in the core triggers the star to expand into a red giant. During this phase, the outer layers of the star swell enormously, while the core contracts and heats up. This intense heat allows the star to fuse helium into heavier elements such as carbon and oxygen. As the red giant phase progresses, the star becomes increasingly unstable. Eventually, it sheds its outer layers, creating a beautiful and delicate structure known as a planetary nebula. At the center of this nebula lies the core of the star, now a white dwarf, a dense, Earth-sized remnant composed primarily of carbon and oxygen. The white dwarf no longer undergoes fusion. Instead, it slowly cools and fades over billions of years, becoming what is known as a black dwarf, a hypothetical object that has yet to be observed in the universe due to the immense timescales involved. The story is far more dramatic for stars with masses significantly greater than our Sun. These massive stars evolve much more rapidly, burning through their nuclear fuel at a tremendous rate. After exhausting the hydrogen in their cores, they too expand, but into a much larger and more luminous red supergiant or blue supergiant. In the core of a supergiant, fusion continues with heavier and heavier elements. Helium fuses into carbon, carbon into oxygen, and this process continues, creating layers like an onion, with each shell of the core burning a different element. The star's core becomes a furnace, generating elements up to iron. But iron is a dead end. Fusion of iron does not release energy. Instead, it consumes energy, leading to an unsustainable situation in the star's core. When the core accumulates too much iron, it can no longer support the star against the relentless pull of gravity. The core collapses in a fraction of a second, triggering a supernova explosion, a titanic release of energy that can outshine entire galaxies for a brief moment. This explosion blasts the outer layers of the star into space, enriching the cosmos with heavy elements like gold, silver, and uranium, elements that are essential for the formation of planets and life. The remnant left behind after the supernova depends on the mass of the original star. If the core's mass is between about 1.4 and 3 times that of the Sun, it becomes a neutron star, a city-sized object so dense that a single teaspoon of its material would weigh as much as a mountain on Earth. Neutron stars can have extreme magnetic fields and spin at incredible speeds, emitting beams of radiation as pulsars. But if the core is even more massive, it collapses further, creating a black hole. A black hole is an object with gravity so strong that not even light can escape its pull. The event horizon of a black hole marks the boundary beyond which nothing can return. These objects are among the most mysterious in the universe, warping space and time in ways that challenge our understanding of physics. Black holes can continue to grow by accreting material from their surroundings or by merging with other black holes. In some cases, they can even consume entire stars, pulling them apart in a process known as spaghettification, where the immense tidal forces stretch and compress the star into a thin stream of gas. The death of stars, though an end, is also a beginning. Supernova explosions scatter the building blocks of planets, moons, and life across the universe. Neutron stars and black holes, the remnants of these colossal events, continue to influence their surroundings, driving the formation of new stars and shaping the galaxies we see today. In the grand tapestry of the cosmos, the death of stars is a crucial thread, a process that ensures the continuous recycling of matter and energy, giving rise to new generations of stars and the potential for new worlds. The death of a star is not just the end of a celestial body, it is a fundamental process that connects us to the very origins of the universe. As we look up at the night sky, we see the light of stars that have long since perished, their final moments still traveling across the vast distances of space to reach our eyes. In their deaths, these stars have shaped the universe and ultimately us. The atoms in our bodies were forged in the hearts of stars that lived and died billions of years ago. In this sense, the death of stars is not just an astronomical event, it is the story of our own origins. Thank you for watching. Explore more about the universe with us by subscribing to our channel.